Hi, Louisa. Thanks for asking this question. So there's a couple parts to this that we have to get through. The first is solving the problem. And so what I'll do is I'm going to show you how to do that kind of in the simplest way. So what we have here is we kind of have one of these, famous questions in physics where it's sort of split into two parts. We've got the two cars colliding, which we know is a collision, but then we also have just a car rolling down a hill. So the best thing to do is to sort of consider it in two sort of parts. We've got the car at the top of the hill, um, the car at the bottom of the hill, right? That's our start. And we know our end is the two cars are stuck together and then moving off like that. But we have some middle part, and that intermediate stage is where now our lighter car, M1, is at the bottom of the hill, and it's just about to collide with M2, but it hasn't collided yet. So it has some speed V1, and M2 has no speed. So what we're going to do is first we're going to find that speed V1. Now the way we want to do that is we're going to consider what kind of energy does M1 have. If we consider the car 1 Earth system, what kind of energy does it have? Well, it has gravitational potential energy, right? And so at the bottom of the hill, if there's no friction, that gravitational potential energy is all going to turn into kinetic energy. So what's that gravitational potential energy? That's going to be m1 times the acceleration due to gravity times h, height, this height, right? But we don't have that height. We do, however, have the hypotenuse. So we can do d times the sine of theta. For the kinetic energy, it's going to be 1/2 mv squared. I'm calling it v1 because we're going to use it in the next equation. Well, this m1 and that m1, they're the same. So if we solve this out, we get this. That's going to be the speed of the first car when it hits the bottom of the hill. Now it's going to collide with the second car. The key word here is that they stick together. So if they stick together, that means that not all energy was conserved as kinetic energy. There was some energy of deformation. There was the sound of the crash. There was the cars changing shape. And so this is a big sign that we have an inelastic, well, once I learn how to spell, an inelastic collision. So inelastic collision means that we can't use the kinetic energy at the beginning equals the kinetic energy at the end, right? So in this case, we have car 1 with a certain speed, car 2 with a certain speed, and they'll end up as a single object traveling. Call that VF for V final. So the speed of the second car, it's at rest at the bottom of the hill, right? So that's going to be 0. So what we're left with is if we divide m1 plus m2 on both sides, we get VF equals m1 over m1 plus m2 times v1. But we already have v1. So we now know that the final velocity of the two cars is this ratio m1 over m1 plus m2 times the square root of 2gd sine theta. And we can plug in all those numbers at will. So the final question is, what are the open and closed systems here? This is a little bit of a more confusing question. This probably is the way that I would solve it because it's the easiest. But when we're dealing with open and closed systems, what you want to consider is you could consider M1 as an open system, or as the only system, right? And you would have the force of gravity doing work down the hill, and then it would have a certain speed. And then when it runs into M2, M2 would not be part of the system, so we would consider the force of the impact on M1 as a force acting over time. And so that would exert a certain impulse, right? Lowering the momentum from M1v1 to M1vf. But impulse is a force over time, right? Or for your calculus-based integral FDT, force over time. And we don't have a time for the collision. So you can consider any one of these individual things as its own system, or you can pair them up in any which way you would like. Sort of doing the M1 and Earth to get your speed, and then recalibrating and switching to M1 and M2 as your systems is going to give you the easiest answer. Probably if your teacher's asking about closed and open systems, what they're looking for is some sort of discussion on, okay, what if I just look at M1 alone, and then, force of gravity is doing work, imparting speed, imparting momentum. And then the collision with M2, the force of M2 on M1 is doing work. But if you plug your numbers in here, you should get the answer. I hope this helps, and if you would like further tutoring, please feel free to reach out to me. Okay, thank you.